Hey everyone, welcome back to my channel EduVibe. Today we'll start with another topic of the Unit B of grade 11 chemistry, which is the forms of gas and gases. And today we're doing the topic which is called the Boyle's law. So now we start with the laws. Today we're doing the Boyle's law, next we do the Charles law, and then combined gas law, and then the ideal gas law. So these are some laws and that have the formulas and which you have to memorize them. So first that law which says that, so you have to know some theory of this, that Boyle's law states that the pressure on the gas increases if the pressure is increases, so the volume of gases are decreases. So the relationship from the pressure and the volume, that if pressure is increases, so the volume is decreases, which tells us that volume is inversely proportional to the pressure. If pressure is increases, volume is decreases. If pressure is decreases, volume is increases. So that's the relationship of that law. Proportionally provide that the temperature and the chemical amount of gas remain constant. So that chemical amount of gas is the N and the temperature is T. So that both things should be constant. So we are just dealing with the pressure and the volume. So in the other words, volume is inversely pushed to the pressure, as I told you over there. Increasing the pressure forces gas molecules closer together and decreasing the volume in that case, as we do in the when we do the ideal gases and the real properties. So that property is all applied to this concept. Decreasing the volume results in the more frequent collisions between gas molecules and a container increase in the pressure. This will increase the pressure because the volume is decreased, so collisions occur between the gas molecules, which will increase your pressure of that gas molecules. So we have two types of graph in that case. We have volume versus pressure. So volume versus pressure, as the volume, if the volume is like the volume is increased in 20 like in this, and the pressure is decreased. Pressure is over there is something like very decreased. So as the volume goes down, volume become decrease and the pressure will increase. So that's the relationship we do. They are inversely proportional. But if the volume versus the inverse of the pressure, if there is an inverse, so they or both are like this. They both are doing a straight line thing. If this is increased, this is also increases. Increasing by the volume or the pressure, both are increased by the same time. So that's the relationship of this. So from the relationship from that two things, we that really the formula we like made the formula which says that P1 times V1 is equal to P2 times V2. So here P1 is initial pressure, P2 is the final pressure, V1 is initial volume, and V2 is the final volume. So that when you have a question, like when you have discussed in the next slide, that when you have questions, you have to recognize that which is P1, which is V1, which is P2, which is V2, and one of the things we have to find from the this. So note that any units of the pressure and volume may be used as long as the same units are used for all the measurements. So as I told you, if you have a one volume in milliliters or other volume in liters, so we have to in the same units, or the liters or the milliliters. Basically, we're doing the liters, not the milliliters. And in pressure, we know number of the units in this, so make sure they are both are in the same. So let's move on to the example of this. So the 2.0 liter party balloon at 98 kPa is taken out to the top of the mountain where the pressure is 75 kPa. Resume that the temperature and chemical amount of gas remains the same. So if they mention that they remains the same, this means they'll talk about the Boyle's law. Use the Boyle's law to determine the new volume of the balloon. Basically talking about that we have the pressure of a party balloon. So this is V1, and this 98 kPa at that, if the volume is this 2.0 liters, this means the pressure is 98 kPa, which is our P1. And then it taken to the mountain, and then the pressure is 75. So pressure is changed to 98 to 75, which is P2 now, and we find the new volume. New volume means we have to find the V2. As we know that P1 V1 is equal to P2 V2, and to find the V2, so I have to isolate the V2. So V2 is equal to P1 V1 divided by P2. So P1 we have 98 kPa. You see that we have kPa and kPa. This is liter. So the V2 is also in B calculated in the liter. So nothing have to be conversion. So V1 is 2.0 liters divided by 75 kPa. So kPa. So kPa cancel out and we get V2 of about. So when we calculate it, we get the in liters. So which is 2.613 liters, which we get into set this, which is 2.6 liter. So from here we get the V2, which is the volume of the balloon at the top of the mountain. So that's how you can use that formula. You find that something they call about a V2, then you call about P2. Anything you have to find, just isolate that thing and get the values in and calculate this out. Let's move on to the next one and get more clarity of this topic. So they're talking about the bicycle pump contains 0.650 liter of air at 1.101 kPa. If the pump is closed, what pressure is required to change the volume of to 0.250 liters? They change the volume. So if the first volume is this, if a if a V1 is this, so this means they change to this volume, so which is V2. At that 0.650 liter of the volume, we have a pressure of this, so this is P1. And what the pressure is at this, so we have to find the P2 now. So again, we use same formula. Now we isolate the P2 from here. So P2 is equal to P1 upon V1 upon V2. So all units are same. So use that unit. So P1 is 101 kPa. V1 is 0.650 liters and V2 is 0.250 liters. Now the liter liters cancel, and when you calculate or multiply and divide, you get 262.6 liters, and we want in 3 set this now. So 263 liters, and we get this also in liters. So that's how to find that. So anything you have, you just put in the things. You just have to recognize that which is Vy, which is P1 in the equation, and the P2 and P2. So that's all I have to do. This is an easy thing. And next law is also easy. The laws are very easy. You just have to memorize the formula in this. So that's all for this lesson. The next lesson we start with the Charles law, which is again like the same kind of law, which will include the temperature in this now. So learning made simple, EduVibe, learn smarter but not harder. Please like, share and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, get it with EduVibe.